Today I am going to explain a very important rule of exponents, and that is when two exponential forms have same basis on both sides of equality, then in that case their indices must also be the same. So if a raised to the power m is equal to a raised to the power n, then m must be equal to n. But this is not the complete statement. This is incomplete statement. So the complete statement is if a raised to the power m is equal to a raised to the power n and a is not equal to minus 1, 0 and 1, and except these three numbers, a may be any real number. So a belongs to R minus curly bracket minus 1, 0, 1. Then m is equal to n. So if this complete statement is not understood well, very funny results we can obtain. So suppose this condition is not given with this rule, only this is written a raised to power m is equal to a raised to power n, it implies that m is equal to n. Then as you see, minus 1 raised to the power 2 is equal to minus 1 whole raised to the power 4. So according to this rule, 2 is equal to 4, which is funny and absolutely wrong. 2 cannot be equal to 4. Similarly, 0 raised to the power any exponent 3 is equal to 0 raised to the power any other exponent like 5 or 7 or 6. So according to this rule, if additional condition is not given, we may say that their bases are same and their exponents are must also be same in that regard, which is also wrong. Same is true for 1. 1 raised to the power 7 is equal to 1 raised to the power any other exponent like 10, 11, 12, 13. So we have an invalid result. 7 is equal to 10 and so on. So you see, these funny results are obtained if we don't include this condition: a is not equal to minus 1, 0, 1. So the complete statement is when a raised to the power m is equal to a raised to the power n, when a is not equal to minus 1 or 0 or 1, then m must be equal to n.